Welcome to the session. Greeting of the day. In today's class, we are going to talk about the programmable logical devices. We have a few devices named as microprocessor, microcontroller or microcomputers, and the PLC, programmable logic controller. These three we are naming as a programmable logic devices. We are naming as a programmable logic devices. So these devices I am naming as number 1 as microprocessor, number 2 as microcomputer or otherwise as a microcontroller, and the number 3 as a programmable logic controller, the PLC, the most important factor in this electronic industries with respect to mechatronics, which helps, PLC helps in controlling the mechanical systems through electronic devices to control the operation of the electromechanical devices. That is done through the PLC. We will go one by one. The programmable logic devices to perform different control functions according to the program written in its memory. So we are going to control some of the functions which is related to mechanical. Which is related to mechanical functioning through the electronics. According to the program which we have done on the memory, which is stored as like we can. Now we can think about a computer. This computer contains the memories and the various wirings of buses and the input-output ports and the hardwares of keyboards and mouse and monitors, arithmetic logical units, everything is this computer contains. Those computers having a part of a microprocessor. This processor does the job. Input-output, it is a mouse and keyboards. But where these arithmeticals are done, where these logicals are done, all these things are done by this processor. So this to perform different control functions according to the program written in its memory using low-level language of the commands. Now we come to one by one. Microprocessor number 1. The digital integrated circuit, a digital functioning necessary to process those information. To process those informations which are in the memory. We have first feed it, we have programmed well this to be happen, this feedback system to be happen, this closed loop system to be happen. We have fed it to the memory. From the memory to the output, the connector is nothing but a microprocessor. Takes the memory, functions and gives input and it takes the output. What happening? So that is job done with the microprocessor. Similarly, some other categories of microcomputer uses this microprocessor. We are using this microprocessor as its central processing unit CPU and contains all the functions of computer. So microprocessor is a part of this microcomputer or microcontroller. So microprocessor we have taken and along with this microprocessor, I am typing as MP microprocessor, we will have input outputs, memories such as RAM, such as ROM, all together will function as one for one job, for one specific task. Here I have a fixed RAM, the fixed 2 memories, we have mobile, we have microcontroller there. We have fixed amount of memory, fixed amount of ROM to the function to store these programs. We want to operate a remote. There we have the microcontroller to do a single specific job. So there we are using a microcomputer which contains all, and additionally the microprocessor also the integrated part of this microcomputer. But not here, this is the actual computer. The actual computer uses the microprocessor separately. The RAM we can able to add from 4GB to 8GB, 8GB to 16GB, we are additionally we can able to insert. But here in the microcomputer it is a fixed one chip which contains all together. But here microprocessor chipset is different, RAM is different, ROM is different. We can add input, multiple input we can add, outputs we can add, those things we can able to do. So by this we understand this two of microprocessor and microcontroller, then the programmable logic controller is there. So we are using the memories, programs to operate a function of a simple conceptual closed loop system. Here, this PLC we are using to control the electromechanical devices. I want to on the motor for specific time. I have programmed and feeded it to the device of logical device PLC, and this PLC will operate those functions without computer. Because we have already programmers has been fed to this PLC setup. So likewise are there. Microprocessor to microcomputer. Microcomputer is a data processing system that employs a microprocessor as its central processing unit. So it is like a mini computer. Microcomputer is nothing but a mini computer does some specific task which contains the inbuilt microprocessor. Inbuilt microprocessor for a single task like that we can keep. So other variables I want to define here. Before going there, you see this microcomputer contains a microprocessor here. This processor does the arithmetic logical units and the control operations. If not to go and or not, so those functions will be done by there. And the three terminologies I want to mention. One is a data bus. One more is a control bus. This is number one. This is number two. And the third one is address bus. So these three I want to mention. These three are connected to the input and output. You see now, this data bus is connected to the 1, to the 2, to the 3 connected. Because input output we have these three layers: data bus, control bus, address bus. All together should receive to the input output. Then only what is the data? What I want to do with the data, and where is the data? I have stored the data in the D folder, that is address, and I want to take the data and I want to delete or I want to modify, that is a data, we are doing the control actions, and that data is named as a Word document or this Excel sheet. So likewise we are main data, but the data is nothing but information, a program in where we have saved. This program is saved in the D column, and that program contains information to operate the remote. That remote to be controlled, the controlling action. So I am dividing into three sections here. Program, and what we have to do with the program, whether modify the program or delete the program, what we have to do, the control action, on the program, off the program, positive program or reduce the program, subtract the program, mathematical program, what control action we are doing there. So that things and where it is available. So these three informations to be included to the input output. Therefore, this I have included here 1, 2 and 3. And second one you see here. So this one I am taking the control bus. So I have taken this one control bus. I have mentioned as 1. Here it is connected. Again this control bus is connected here also. So here also it is connected. Connected, and then again it is similarly connected to 3. It is coming here, coming here, and it's coming here. And then now the third one I am taking again, and third one I am taking to the address bus. So see, the address bus is coming from here. Address bus is coming from here. Number 1, number 2, similarly number 3. So these three connections you should give. Data bus to the input output, control bus to the input output, and address bus to the input output. So this sketch that we have made to understand it is coming to 3. It is input output is a common one. Input outputs, which input we are giving multiple inputs are there, multiple outputs are there. Accordingly we are adding some pen drives in one port and copying to the other ports. So such things are done. Input output ports are, we are given multiple inputs, multiple outputs process. So all are connected again to the memory unit. So here this database is connected here to the memory, and then this control bus is again connected to the memory, and then again this address bus also connected to the memory. So all these things are interlinked. Logical units, memory units, and the various buses with respect to input output ports are interconnected. We are naming this as a microcomputer. Microprocessor is one of the component of this microcomputer. We are telling like this. So bus, a digital signals moves from one section to the another along the path. I am naming this is a bus. A bus, a number of parallel conductors. We can use this. Carry electrical signals, which we are don't. And the next one I am telling about the data bus. A data associated with the process information. What data we have taken? What data it is? Binary data, number of values, what it is. So data we are taken here. So 4-bit word says 1010 from some 4 wires. So some data we are taking. So force ranges 20 to 180 newtons, or strains or span levels are 160 newton. So some data we are giving as an input. Like for mechanical side, we can consider the tensile strength data, toughness data, some mathematical data. So whatever it is, a group of information we have taken there. So and then the address bus, it carries a signal which indicate where the data is to be found. That is, I am giving example of D colon or D colon, E colon, where it is available. Where should I take? Where should I save? So thus the data are going through the address bus. Bus we have mentioned as group of wires. So this is the same examples. And the control, what function we have to do? Subtraction or addition or multiplications. Signals are related to the control actions. Example, to read the data or write the data. Only viewing a PDF is reading the data, and deleting or re-editing the data in the Word documents is writing the data. So some control actions we are doing there. So such cases we can able to do. So microprocessor programmable controllers, I am dividing further into 2 categories. A controller or microprocessor based controller. Microprocessor, we know what it is now. Doing this arithmetic logical operations. We can add memory, we can add inputs, output ports. So microprocessor is a separate device like i5 processor, i7 processor. So latest we have those things. So now it is subdivided into 2 categories. It means the microprocessor available in these 2 also. Microprocessor available in programmable logic controller of PLC. Microprocessor is available in this microcontroller. Inside also microprocessor is available. Microprocessor plus RAM plus ROM plus input port plus output port. So these things are fixed. We are naming this as a microcontroller. Now one by one we will see. So that is a microcontroller now. Microprocessor based system. Yes, it is a microprocessor based systems. Implements the function of a computer and the controller on a single chip. This word is important now. Control on a single chip. Typically programmable for one application. See what I mentioned there in the introduction. Typically programmable for one applications. Dedicated to specific control functions. Dedicated to one specific functions only. We are using in the automobiles, aircraft, medical, everywhere, home appliances, all we are using. Some applications I have given here. Some of remotes, mouse, players, music players, power tools, toys. We have to toys are made up of microcontrollers. It should move forward operations. It should come backward. It should rotate. Only some small toys, only one operations they are doing. So such cases we can use in the microcontrollers. And I have added the USB device also. You see, for example, USB device also having our remote. This remote also having also microcontroller. So what are they? We have the central processors, memories, and input-output ports, and all those things we have into the account. So this microprocessor-based systems are, it is very small and can be embedded in a electromechanical systems without taking up much space. So what we are doing, it's a small and can be embedded all together. Embedded means this processor, memories, input output ports, buses, all together embedded in a electromechanical systems. We can consider the toy as an electromechanical systems. Electromechanical system without taking up much space. Functions are completely designed into a single chip. Very little user programmable memory. It uses only one memory, very less. We don't need of the 8 GB RAM, 16 GB RAM. We don't need, because the task is one, program is one, and we are not changing, we are not deleting, we are not modifying. Then obviously it is small, it is compact. One task, one memory, sufficient small, fixed memory is enough. For example, as of now, Motorola 68HC11 and Zilog Z8, Intel MCS 5196 series all belongs to this microcontroller devices. 8051 is a microprocessor we have. Now we came to these various components of microcontrollers. Up to now we have talked about the microprocessor. Right, you see this also contains the same component of CPU. Here the microprocessor is one of the component along with all. It is also fixed. RAM is fixed, ROM is fixed, input is fixed, output is fixed. For imagine a pen drive for this example. It contains a small CPU to do the job and timing control units, then the analog to digital converters, analog to digital converter unit. Here we have the CPU, timing control units, fixed RAM, registers, temporary registers, and ROMs, and input output serials, input output signals. Here we have analog to digital converters. Here we have a digital to analog converters. So these are all fixed amount. I want to receive a signal which is in analog converted over. There is only one input, and I want going to do the one output. Specific task, specific fixed RAM and ROMs, and then a CPU and a processor to do a single job, to do a single job. So this is the setup or sketch of the microcontrollers. We can say this internal architecture of the microcontrollers. So what is the component now? We have seen the same components. This is the various components we have seen elaboratedly in the microprocessor. You see, this microcontroller contains the same. It contains a microprocessor inside with arithmetic and logical unit. You see, in this diagram we have CPU, same timer control. It have the ALU. It have the ALU here. It has the ALU, arithmetic logical units here. It does. So register array, temporary storage we have seen now. So now we have seen the temporary storage devices. Controls the timing and the control devices. Timer and control, see, timer and control are here, and input output, analog to digital, digital to analog converters. So input and outputs, system buses like address bus, data bus, control bus. This is a fixed connection. Specific task. The same components are available there, but it can able to remove multitasking. We can do undecided outputs we are receiving. Therefore, we are creating, developing the programs and softwares. There we are using the microprocessor. But here it is going to do simple task. Therefore, a component, a lightweight, a light cost, do a one task. The component named as microcontroller, job over. Multiple task, doing heavy works. We need more inputs. We have to connect, disconnect. At the time we are using the microprocessors individually. So here also analog to digital converters, memories, ROMs, RAMs, system buses, all are available in a fixed amount. Microcontrollers. In case of microcontroller, it has a CPU. It has a CPU. In addition with the fixed amount of ROM and RAM, fixed amount of input and outputs, important to line. As on a single chip. In the pen drive we have one input, one outputs taking as a single chip. But it also contains the processor to do the transfer jobs. It also has the address bus, it also has a control bus, it also has a data bus. It also has a memory of 16 GB, 256 GB. So 64 GB of phones we are using. It is designed to perform a specific task, like we are thinking about the pen drive to do the transfer. Specific means where the relationship of input output is defined. The word I have used in the microprocessor, the relationship between input and output is undefined. Now I am defining, I'm giving the statement of for this microcontroller's input and output or relationship is defined, like a remote. Clicking 1, it is does. Clicking 2, it does. Since the application is specific, since we know this now, we are going to do only one task. The microcontroller need smaller resources like memory unit of RAM, ROM and other inputs. The resources itself getting reduction. One task we have to do that it needs only 2 GB of RAM. Why we need to enable 16 GB of RAM there? Unnecessarily including the additional memories increases the cost. Therefore, microcontroller can be utilized where the specific task is needed. Only one job it will constantly and repeatedly it is going to do. At the time you can use. Like a camera also, only one task. Shutter open, shutter down. Click. So those things we can do by this undefined input and output relationship. There we are using the microcontrollers. So the applications of microcontroller, you see, which are defined input outputs relationship will be there. Keyboards, mouse, pen drives, digital cameras, washing machines. These are fixed. One button click, it has to do that specific job at n number of times. Remote, digital watches, microwave ovens, DVD players, MP3 players, mobiles, those things. Here accessories for bike, cars, home appliances, entertainment equipments of toys, ignition timings, anti-lock braking systems in the cars, airbag controls, temperature controls, fuel injection controls and air pressure controls are also is there for applications of microcontroller. In this programmable logic devices, we have started to see about microprocessor, and then in this microprocessor we have seen some examples of washing machine, and then we have seen some examples of temperature control, and then also we have seen some examples of automatic focus camera, So likewise we have seen about this microprocessor, and also we have seen about the microcontrollers. This I have defined as a single chip. We just remember as a single chip contains all together at a one chip, at a single chip all together it contains a single. So that is how we have defined this microprocessor, microcontroller. Then we have seen the comparison between microprocessor and microcontroller. Microprocessor and microcontroller we have seen. So this is how we have done about this today's class. The remaining part of the subject we will see you in the next session. Thank you.